Stripping is the initial phase of the extraction process, involving the removal of overlying geological layers that have shielded the blue limestone for millions of years. This process begins with clearing vegetation and topsoil, followed by the excavation of clay, silt, and less valuable limestone. Heavy machinery, such as excavators and bulldozers, systematically removes these layers, which can be up to 20 meters thick. Marking involves carefully identifying key areas on the limestone benches, such as veins and breaks, to guide accurate cutting. Bench cutting uses diamond-tip chainsaws to slice limestone precisely. The rail-mounted coal cutter has a 6-meter diamond-segmented cutting arm, efficiently slicing limestone benches lengthwise at a steady pace. The crawler-mounted coal cutter is a powerful machine designed for precise transverse cutting of limestone benches. Moving on tracks, it operates at an average speed of 4 to 8 cm per minute. Equipped with a diamond-segmented cutting arm, it ensures smooth, accurate cuts, optimizing block extraction while minimizing waste and preserving the stone's natural integrity. Stone splitting uses hydraulic spreaders to break large limestone blocks. Hydraulic spreaders are specialized tools used for splitting large limestone boulders into smaller, more manageable blocks. After drilling precise holes along natural segmentation joints, operators insert the hydraulic spreaders, which exert controlled pressure to gradually force the stone apart. This method ensures clean, efficient splits while preserving the stone's structural integrity. By applying uniform pressure, hydraulic spreaders minimize material waste and create evenly sized blocks, which are then processed further for construction, tiling, and decorative applications. Squaring off is a crucial step in the processing of blue limestone blocks, ensuring they meet the strict quality and dimensional requirements for further transformation. Once large limestone blocks are extracted, they are transported to a designated raw material processing area. Here, advanced wire cutting machines and mobile saws are used to trim irregular edges, creating well-defined rectangular or cubic shapes. This process enhances efficiency in later stages by reducing material waste and optimizing the stone for cutting, polishing, and finishing. Blocks that fail to meet strict quality criteria, due to structural inconsistencies or impurities, are repurposed for industrial use, such as aggregates or gravel. Precision in squaring off is essential for ensuring that each block maintains uniformity, facilitating smooth processing in sawmills and finishing facilities. During the sawing process, blue limestone blocks are cut into slabs using gang saws with 4-meter-long diamond-segmented blades. These saws operate continuously, cutting at a speed of approximately 30 cm per hour. The cutting motion is deliberate and precise, ensuring that each slab remains smooth and uniform in thickness. This careful, slow cutting process is essential for preserving the stone's structural quality and preparing it for the next stages of finishing and application. In the drilling phase, specialized machinery called drill rigs is used to bore deep vertical holes into solid rock. The crew carefully selects the location for drilling based on the desired rock fragmentation. Drill bits, often made of hard, durable materials like tungsten carbide, are used to penetrate the rock. The process is precise, as the depth and diameter of the holes directly affect the effectiveness of the subsequent blasting. Water or air is often used to clear debris from the holes. Once the drilling is completed, the next critical step is blasting. The drilled holes are carefully filled with explosives, typically dynamite, though other types of explosives may also be used depending on the conditions. If the hole contains water, a special water-resistant explosive is used to ensure it detonates effectively, while dry holes may require a different type of explosive designed for arid conditions. The explosives are placed deep within the holes, ensuring that the explosion will cause the most efficient fragmentation of the rock. Each explosive charge is carefully placed to optimize how the rock breaks. The charges are packed into the holes and connected by detonating cords or wires, all linked to a central detonation point. This setup allows for precise timing and synchronization of the blast. Often a combination of dynamite sticks and blasting caps is used. The blasting cap, an initiator that causes the dynamite to explode, is inserted into each charge. Once everything is in place, the crew will retreat to a safe distance, and the area is cleared of all personnel. When the charges are detonated, the result is a powerful explosion that fractures the solid rock into smaller, more manageable pieces. The blast is designed to create fractures in a controlled pattern, breaking up the rock into chunks of various sizes. The intensity of the explosion is enough to crack and splinter the rock, but it is carefully engineered to prevent excessive vibration or flying debris, which could pose a risk to surrounding areas. Following the explosion, the resulting broken stone is collected and transported to crushers. These crushers break the rock down further into smaller aggregates, which are used for various construction purposes. The crushed stone serves a range of functions, from being a key ingredient in concrete to forming drainage materials around foundations, and even being used in the production of asphalt for road construction. The entire blasting and crushing process ensures that the quarry provides the necessary materials for large-scale construction projects. Drilling involves surveying the quarry face, designing blast patterns, and drilling precise holes in bedrock to place explosives safely. The process starts with a detailed 3D survey of the quarry face, capturing precise measurements of the rock structure. This helps engineers design an effective blasting plan, ensuring safety and efficiency during extraction. The survey data helps the explosives engineer determine the optimal placement, depth, and amount of explosives needed for efficient rock fragmentation. The engineer uses the survey data to map precise shot hole locations, ensuring the blast is controlled, minimizing risks, and maximizing efficiency. Holes are carefully measured and drilled into the bedrock using specialized equipment, creating space to insert explosives for rock fragmentation. Explosives are detonated to fracture rock, separating it from the quarry. After placing explosives in drilled holes, they are carefully detonated to create a controlled explosion. This forces the stone to fracture and break away from the quarry wall, allowing for easier extraction. After blasting, loaders gather rocks and haul them to crushers. After the blast, a loader clears the shot pile, organizing the debris before loading it into dumper trucks for transport to the crusher. Large haul trucks are used to transport the broken rock from the quarry to the processing plant. These trucks are designed to carry heavy loads, ensuring efficient movement of material for crushing. Crushed rock is sorted and screened into different aggregate sizes. Primary crushing is usually by a jaw crusher, consisting of a heavy metal plate, which moves backwards and forwards against a fixed plate. The output from the primary crusher is conveyed onto the primary stockpile from which the secondary crusher is fed. The output from cone crushers is transported via conveyors to a screen house, where it's sorted into various aggregate sizes using vibrating screens, where large multiple deck screens sort the crushed stone into the required aggregate sizes. The Copper Mountain Mine project is an open-pit copper and gold mine located near Princeton, British Columbia. The project began construction in 2008 and took 2 years to complete, with over 1 million logged hours of work. It officially commenced production in the summer of 2011 and has since become an important part of the local economy, providing jobs for approximately 400 people and contributing hundreds of millions of dollars to the provincial economy. The mine is a joint venture, with Copper Mountain Mining Corporation holding a 75% stake and Mitsubishi Materials Corporation owning 25%. The mine is based on a resource of 5 billion pounds of copper and is expected to produce significant quantities of copper, gold, and silver over its 17-year lifespan. Capital costs for the project totaled $438 million, with financing achieved through a 75/25 debt-to-equity ratio at attractive interest rates. During its operational life, the mine is expected to produce approximately 1.5 billion pounds of copper, 450,000 ounces of gold, and 4.5 million ounces of silver. The mine also utilizes a fleet of mobile mining equipment, including hydraulic shovels, 240-ton haul trucks, and rotary drills, all of which are supported by a new 5-bay maintenance shop. The process at Copper Mountain Mine is efficient and state-of-the-art. Ore is delivered to a primary crusher, where it is reduced to about 6 inches in diameter. From there, it is conveyed to a concentrator where the ore is processed through a series of stages, including grinding in a SAG mill, further grinding in ball mills, and flotation to separate copper minerals. The final product is a copper concentrate containing 25% copper, as well as gold and silver. This concentrate is then trucked to the port of Vancouver in preparation for shipping to Japan for refining and smelting. Exploration at Copper Mountain Mine continues, with the company focusing on expanding the resource through ongoing drilling. The mine's long-term goal is to maximize production, minimize costs, and become a world-class copper producer. With its significant resources and growth potential, the Copper Mountain Mine is poised to remain a valuable contributor to both the local community and the global mining industry. The Pirgon Quarry, located in the prefecture of Drama in northern Greece, is one of the largest white marble quarries in Europe. Situated near the village of Pirgi, the quarry has become renowned for its high-quality marble extraction. Operations at the quarry began in 2003, and since then, it has grown into a significant player in the marble industry. Spanning an impressive 348 acres, the quarry boasts an annual production capacity of 160,000 tons of marble blocks. The quarry is meticulously designed for efficiency, with its operations organized across 24 layers. This ergonomic structure allows for optimal extraction of marble, ensuring minimal waste and enhanced productivity. Despite the scale of the operation, the quarry places great emphasis on adhering to environmental regulations. Every area of the quarry has been carefully crafted to blend seamlessly with the natural landscape, with the construction of a 20-kilometer road network, enabling easy access to all locations within the quarry. With more than 200 employees working across various levels of the operation, the Pirgon Quarry not only contributes significantly to the local economy, but also provides a model of sustainable quarrying practices. Its marble, prized for its purity and exceptional quality, has found its way into major construction projects across the world, solidifying its position as one of Europe's leading marble producers. The quarry stands as a testament to modern, environmentally conscious extraction techniques, and its success reflects the growing demand for high-quality natural stone. Yashika Granites Mines, located in India, is renowned for its high-quality Majestic Black Granite, a material highly prized in the stone industry for its fine composition and striking visual appeal. The Majestic Black Granite found here is a metamorphic and weathered igneous rock, characterized by its deep black hue and a subtle yet sophisticated texture, making it a preferred choice for both commercial and residential projects. It is used extensively in construction, countertops, monuments, flooring, and other architectural applications due to its durability, aesthetic appeal, and polished finish. The Yashika Granites Mines site spans over an impressive 5 hectares of land, providing ample space to support its extensive mining and production operations. This area houses various facilities that are essential for every stage of the production cycle, ensuring efficient and high-quality processing of granite. The quarry is equipped with heavy-duty machinery designed to excavate and transport the raw material. These machines play a critical role in the initial stages of production, enabling the safe and efficient extraction of granite blocks from the quarry. In addition to excavation, the facility is equipped with state-of-the-art stone working machines that handle the intricate details of stone processing. The workshop yard features a derrick for hoisting and lifting, which aids in the transportation and storage of heavy granite blocks. This is crucial for managing the raw material and ensuring it is moved safely through the various stages of processing. The block cutting machines at the site are central to the production of both marble and granite slabs. These advanced machines provide precision in cutting, ensuring that each slab is crafted to the highest standards of quality and finish. Furthermore, stoneworking machines are used for dressing and finishing, ensuring that each piece meets the specifications required by clients. The Tokyo University of the Arts, Tokyo Gaidai, recently hosted a fascinating stone-splitting demonstration, showcasing traditional and modern techniques used in stone craftsmanship. This event provided students, artists, and enthusiasts with a rare opportunity to witness firsthand the precision and skill required to split stone effectively. The demonstration featured methods that have been used for centuries in Japan. Skilled artisans used chisels, hammers, and wedges to carefully create controlled fractures in the stone. One of the key traditional techniques involves placing small metal wedges, called kanami-ishi, into pre-made grooves and tapping them rhythmically. This technique allows for a clean and controlled split, a method that has been passed down through generations of stone craftsmen. In addition to traditional techniques, the event also introduced modern stone splitting methods. This included hydraulic splitters and diamond cutting tools, which allow for more precise and efficient cutting. While traditional methods rely on manual skill and experience, modern machinery enhances precision and reduces the physical labor involved. Stone craftsmanship plays a significant role in Japanese architecture, sculpture, and landscaping. The event highlighted how stone splitting is crucial in creating everything from temple foundations and gravestones to contemporary sculptures. Tokyo University of the Arts, known for its emphasis on traditional and contemporary art forms, frequently hosts such demonstrations to ensure that ancient techniques continue to be appreciated and preserved by new generations of artists. The demonstration was not only a showcase but also an educational experience. Attendees had the chance to interact with artisans, ask questions, and even try their hand at using chisels and wedges under expert guidance. Shodoshima, a small island in Japan's Seto Inland Sea, has a long history of stone craftsmanship. One of its most remarkable traditions is stone splitting, a technique that has been passed down for generations. This method, which dates back to the Edo period, 1603 to 1868, involves using traditional tools to carefully split large stones with precision. Unlike modern stone cutting techniques that rely on heavy machinery, the traditional approach uses simple yet effective hand tools such as chisels, hammers, and wooden wedges. Skilled artisans identify natural cracks in the stone and apply pressure gradually, allowing the stone to split along its natural lines. This technique requires patience, expertise, and a deep understanding of the stone's structure. In recent years, there has been an effort to preserve and revive this historical craft. Artisans and historians have worked together to recreate Edo period tools and demonstrate traditional stone splitting techniques. These efforts not only celebrate Shodoshima's rich cultural heritage, but also help educate younger generations about sustainable and environmentally friendly craftsmanship. Visitors to Shodoshima can witness live demonstrations of stone splitting and even try their hand at the process under expert guidance. This hands-on experience provides insight into the island's historical craftsmanship and the skill required to work with natural materials. Stone carving is an ancient and intricate craft that involves shaping stone into sculptures, architectural elements, or decorative pieces. One of the traditional techniques used by sculptors is wedge splitting, also known as plug and feather or wedge and shim method. This technique allows sculptors to break large stone blocks into manageable sizes with precision and control. Wedge splitting involves inserting metal wedges into pre-drilled holes in the stone and gradually applying force to create a controlled fracture. The process follows these steps: marking and drilling. Small holes are drilled in a straight line along the stone's surface. Placing wedges, each hole is filled with a combination of metal wedges, plugs, and thin metal shims, feathers. Applying pressure. The wedges are hammered or tightened to exert even pressure, causing the stone to split along the drilled line. This technique is widely used for cutting large stone blocks in quarries and shaping stones for sculptures and buildings. It is preferred because it offers precision, less waste, and preserves the stone's natural structure compared to other cutting methods. Traditional and modern sculptors use various tools to refine and shape stone after splitting. Some essential tools include point chisels for rough shaping and removing excess stone, tooth chisels used for refining surfaces and adding texture, flat chisels for smoothing and fine detailing, hammers and mallets to apply force when chiseling, grinding and polishing tools for finishing and enhancing the stone's surface. Stone carving is a skill that requires patience, precision, and mastery of tools. The wedge splitting method, combined with specialized carving tools, allows sculptors to create stunning and durable works of art.